All right, let's get right into it. We're going to talk about a true automotive icon. A car that didn't just create a new category, it pretty much became the category. Of course, I'm talking about the Volkswagen Golf GTI. But you know, this isn't just a story about a car. It's really about the incredible piece of analog engineering ticking away under its hood that made that whole revolution happen.
You know, Hagerty UK just hits the nail on the head with this quote. Before the GTI came along, if you wanted a fast car, you were usually looking at something fussy, kind of impractical, right? The GTI just changed the entire game. It was proof that you could have a car that was an absolute blast to drive, but you could also, go get groceries in it. It set a standard that basically everyone else has been chasing for decades since.
But here's the kicker. The GTI was never supposed to happen. It wasn't some big corporate master plan. The whole story is just fantastic. It was actually an unofficial, off-the-books project, cooked up by this small, passionate group of VW engineers who saw potential that, frankly, the top brass just didn't. They were basically just building the car that they wanted to drive.
And what happened next is it's staggering. Volkswagen's official plan was to build a measly 5,000 of them. That's it, mostly just to qualify the car for motorsport. But instead, they ended up selling almost 500,000 Mk1 GTIs. What they thought was just some niche little project car became this massive global phenomenon.
And the formula for all this success? It was beautifully simple. They took this peppy, rev-happy 1.6-liter engine from an Audi, they dropped it into the feather-light 810-kilogram Golf body, and the result was pure magic. But the real secret weapon, the thing that gave it that amazing throttle response and made it so reliable, was the fuel injection. This wasn't just some nice feature, it was a total game changer that left the finicky old-school carburetors of its rivals completely in the dust.
So you see, the real soul of this car wasn't just in the tartan seats or that cool golf ball gear knob. It was in the mechanical heart that fed the engine. This one piece of technology is what set it miles apart from everything else. So now we're going to zoom in and see exactly what made this thing tick.
We all know this shape, right? The crisp, perfect lines from Giugiaro. It's so iconic. I bet a ton of us even built the Revell model kit of this car as a kid. You see the whole car, the legend, in its final, perfect form.
But just like with that model kit, the real fun starts when you lift the body off. The instructions show you that mechanical core. So that's what we're doing. We're going under the hood, into the engine bay, where the real genius of this car is hiding.
And here it is, the Bosch K-Jetronic. That K stands for continuarily, which is German for continuous, because unlike modern systems that pulse fuel in little squirts, this thing sprayed it constantly. And the most incredible part about it is how it worked.
It worked without a single microprocessor, not one. The best way to think about it is as an analog computer made specifically for fuel. Long before digital ECUs and complex software, this beautiful, intricate system of levers, springs, and fluid pressures figured out the perfect fuel mixture based on nothing more than the laws of physics. It's amazing.
So, how in the world does this mechanical marvel actually do its job? Well, it all comes down to this really elegant, simple relationship between air and fuel. Let's break it down.
Okay, so this schematic might look a little complicated at first glance, but it really just boils down to three main jobs. First, it has to accurately measure the air coming into the engine. Second, it needs to supply fuel at a perfectly constant pressure. And third, it has to distribute exactly the right amount of that fuel to each cylinder.
Let's make that even simpler. Think of it like this. The system takes a breath, measuring the air. Then it pressurizes the fuel. And then its mechanical brain does a quick calculation and distributes the perfect dose. So let's walk through each of those steps right now. First things first, breathing in. This is the airflow sensor. When you step on the gas, the engine starts sucking in more air. That rushing air physically pushes this sensor plate upwards. The more air rushes in, the higher the plate lifts. It's a direct physical measurement of what the engine is asking for. So simple, but just incredibly effective.
Okay, so the system knows how much air is coming in, but how does it figure out how much fuel to add? Well, this is where we get to the absolute genius at the heart of the K-Jetronic, the fuel distributor. This is the system's brain.
So this component here is the fuel distributor, and I want you to notice that little lever connecting it right back to that airflow sensor we just looked at. That simple physical connection, that's everything. That's basically the wiring in our analog computer.
And this right here is the core logic. It is such a beautiful, simple chain of cause and effect. More air rushes in, which lifts that sensor plate higher. That higher plate pushes on the lever, which then lifts a little control plunger inside the distributor. And the higher that plunger goes, the more fuel it lets flow out to the injectors. It's a perfectly proportional, purely mechanical calculation. No ones and zeros, just physics.
But it was even smarter than that. See, a simple one-to-one calculation isn't quite enough for a real-world engine. Sometimes it needs a richer mixture for more power. Other times it needs a leaner mixture to save fuel. The K-Jetronic system actually had clever ways to fine-tune and adapt that mixture for all kinds of conditions.
So here's the basic trade-off it had to manage. A rich mixture, that's more fuel, is what gives you power for acceleration. A lean mixture, less fuel, is what gives you better gas mileage when you're just cruising. The car has to swap between these two states all the time, and the K-Jetronic did it all automatically. And check this out. This is a perfect example of how clever it was. The warm-up regulator. When the engine was cold, a simple little bimetallic strip inside this thing would bend, altering the fuel pressure just enough to trick the system into delivering a richer mixture for a few minutes. This is what made sure the GTI started up perfectly on a frosty morning, all without a single electronic temperature sensor. So let's zoom back out for a second. This incredibly robust, reliable piece of mechanical engineering didn't just power a car, it powered a legend that had an unbelievably long life.
The original production run was just a whirlwind. It debuted back in '75, right-hand drive models showed up for the UK in '79, and then it got that punchier 1.8-liter engine in '82. By 1983, it really seemed like the story was over, as German production of the M1 GTI finally came to an end.
But, as you can probably guess, the story was not even close to being over. The design was just too good to let go.
Because even though German production stopped, the car's tooling was sent all the way to South Africa. And there it was reborn as the City Golf, and it stayed in production for another 25 years, all the way to 2009, a quarter of a century. I mean, that is just a staggering testament to how brilliant that original design and its reliable mechanicals really were.
So all of this leaves us with a really fascinating question to think about. In our modern world of electric cars, where performance is literally dictated by lines of computer code and over-the-air software updates, what can we learn from this, from a purely mechanical system, an analog computer, that solves such a complex problem with such elegant physical simplicity? It's definitely something to ponder.